Is there anyone named Michael here? No. All right, mic check complete. My name is Declan. I'm a solutions engineer at Databricks. I work mostly with startup organizations on the East Coast, primarily helping them onboard onto the platform, get going, understand how to use it, so on and so forth. By show of hands, who here is a Databricks user? All right, so a pretty good number of people. So today, really what we want to focus on is how do we very simply go from, we have our data source, I want to go into Databricks, I want to ingest this data, I want to transform it, I want to create a table and start to get insight from this data. Super, super simple. I think oftentimes Databricks, it's got a lot of different products in it, there's a lot going on, there's a lot to learn. For this session, we really want to keep it simple and just see how we can very quickly and efficiently get access or get insights from our data. All right, mandatory slide. I'll leave this here for a moment. So, what is a lakehouse? I'm assuming by now that some of you have heard the word lakehouse, hopefully at this conference at some point. But we'll just do a quick review of what Lakehouse is. I'll show you a couple more slides on some of the other products that we're going to be talking about and that we're going to show in the demo. And then we'll actually dive into the platform itself, where we'll take a look at all of this in action. So, what is a lakehouse? Well, the best way to talk about this is to start with some context. And so we call this our data and AI maturity curve. So as you mature as a data and AI organization, so too does your competitive advantage in your industry. That's the idea. So to start, at the foundation, companies need to answer questions about what has happened. How many products have you sold? How many people came to your conference? And a data warehouse is a great tool to do this. It's great for writing SQL queries, great for storing structured data. It performs really well, it's reliable, but it doesn't have the flexibility that we need to power the next set of use cases, to ask questions about what will happen. We can't store all different data types in there. We can't use Python, R, Java, for example, to interact with our data. So we need something else. And that's where Data Lake comes in. So now we start to ask questions about what will happen. How many products will I sell? How many people will come to the conference next year? A lot. A data lake, you can store all types of data in there. You can interact with your data in many different languages. It's a little more economical than a data warehouse, but on the flip side, it then, as we like to say at Databricks, is susceptible to becoming a data swamp. And we start to have data everywhere, it's difficult to organize, and it's not great for BI, it's not great for reporting. But it does help with AI and ML use cases. It's the best technology as the foundation to do these use cases. So we have two different technologies that are required to get us to the top of this curve. Oftentimes, with many organizations, this ends up being not just the two, but across different departments, you'll have more warehouses, you'll have more lakes, and then you have data in all these different locations across your organization. And this creates a whole bunch of problems. So we copy subsets of data between the two, maybe data is getting transformed in the second one. Now you have teams across your organization dealing with two different sets of data, and you don't have that single source of truth anymore. So we have these data silos that our teams across our organization are not able to work properly together, not on the same page. As well, incompatible security and governance models. So if we have two different platforms and I have teams that are accessing both and I need to control who has access to what and which platform, I now have to do this at least twice, if not more than that, for the number of additional warehouses and lakes that I add. And then finally, incomplete support for use cases. And this is ultimately this is the value driver. This is what we're trying to do is get to the point where we can execute all of these use cases simply. So you can probably see where I'm going with this to finalize our lakehouse concept. One platform to do all of these use cases. So it's simple in that we have just a single platform to store all of your data, to execute all the use cases where all of your data teams can work together. Open, it's built on open source standards. So the founders of Databricks were also the creators of what's called Apache Spark. Many of you may know Apache Spark. And that was the first technology that kind of launched Databricks into becoming a company. But then from there as well, at Databricks, Delta Lake was created, MLflow was created, and these technologies have become central to the foundations of Databricks. And then multi-cloud, and we see that on the image there as well. Databricks can be deployed on all three major public clouds, so Microsoft Azure, AWS, and Google Cloud. All the data is stored in your data lake, so Databricks does not store any data. I was about to say Declan, I definitely don't store any data, but Databricks doesn't store any data. But we use Delta Lake, as I mentioned earlier, to provide the reliability and the performance that we expect of a data warehouse. So if we're gonna keep it all in the lake, we're getting the flexibility, we can use all different languages to interact with all different types of data, but now we get the reliability and the performance that we need to do our BI use cases as well. Unity Catalog, a tool for governance so that you can govern your data once across your entire organization. And then all the tools to execute all the use cases. So not only does it provide the foundation as the data platform, but then all the tools to execute everything that you need to do from end to end. As I mentioned, with the data lake, you can use all different types of data, structured, unstructured, semi-structured. You can use all different kinds of data formats. Databricks makes it really easy to ingest a lot of this data, and we're going to talk about all the different ways that you can do that. We'll point that out in the platform. The primary way that we interact with data, that we ingest data into the platform, is using what's called the Databricks Notebook. So if you're familiar with Jupyter Notebooks, it's very similar with just a host of additional features on top. Very easy to get going. We're going to create a notebook. It'll be one of the first things that we see. It's Lakehouse aware, so it's easy to access other data to see what other data might be interesting within your organization that could be helpful in your project. And collaborative. I like to describe this like Google Docs in the same way that you might, two people can be in the same document and editing side by side. You can have multiple people in the same notebook working together in different languages. So I load my data, I transform it, I've created tables. Now it's time for me to start getting some value out of it. For today, we're only gonna focus on just building a basic report, visualizing this in a dashboard, but we could go on the ML route as well. So the tool that we use in Databricks is called Databricks SQL to get that value out of our data, to start querying it, to visualize it, and to create our dashboards. So Databricks SQL is very fast performance for BI and SQL workloads. I mention this because it is, of course, built on a data lake. And so typically you wouldn't expect to get that kind of performance. But in reality, it's very competitive with many data warehouses in the industry. There's some great metrics on performance that I'd encourage you to look up online. As well, there's a classic SQL editor. We can see it in the moving image here. That's very common to other kinds of data warehouses, so very familiar UI. And then support for different BI tools. So say you want to plug in Tableau, you want to use Power BI. It's very easy to connect them and start to power those dashboards straight from your data lake. The query editor itself, as I said, very classic SQL editor. We can visualize in the editor as well the results of our queries. It uses ANSI SQL, so very standard version, nothing proprietary. We can save, share, and reuse these queries across teams, and we're going to take a look at some of that functionality too. And then finally, we can schedule these to refresh, and we'll do so in what's called workflows, and we'll talk about that part of the platform in a moment. So I mentioned that you can use Tableau, you can use Power BI, and that's absolutely true. But in the Lakehouse, we want to give you the tools to execute the entire use case from end to end. So we're going to load, transform, create our tables, query it. We're also going to have our dashboards that we're going to schedule to refresh. I'm going to have that sent to me every morning, so I want to see the results of my analysis. One last comment on Databricks SQL. Recently, we've totally GA'd for AWS and for Azure something called Serverless. And so what this is, as the name suggests, serverless compute. So you can instantly attach to compute to power these queries. It as it says, scales fast and intelligently. So depending on your workload, depending on the number of queries, the number of users, it can automatically scale to meet your needs and then scale back down when the time is right. So you're never paying for idle time with compute sitting there. And the last piece we'll talk about is orchestration. So once we've gone through this entire process where I've created my dashboard, I've gotten the insights that I want, now I'm going to keep getting data every day, and I want to keep adding that to my tables. I want that to come all the way through. I want automatically to have my dashboards populated with the most recent results. The tool that Databricks has to do this is what's called Databricks Workflows. Very easy way to string different tasks together so that you can run your pipeline in a notebook. As soon as that finishes, that's going to trigger the dashboard to refresh after that. Just an example of what this looks like. You can see some of the tasks and how they relate to one another. Once one finishes, the next one kicks off, and the next one, and so on. As well, there are features to actually monitor these jobs in real time so you can get insights into how they're performing. And of course, it's a reliable tool for production workloads. Okay, so now we'll get into the fun stuff, and I'll stop pacing back and forth on stage. I just like to move. And so we'll actually dive into the platform. Let me go ahead and pull this up. So I know we have a good crowd of people that are familiar with Databricks. I do want to show as well what the platform looks like when you first dive in. This is kind of the landing page that you'd expect to see when you first log into Databricks. If I want to create a notebook, I'll go to the New tab on the left, and I can click on Notebook, and I'll go ahead and create that notebook. If I have notebooks that I already want to use, I can click on Workspace, and I have all of my files organized in there. I can select my notebooks, and I can dive right in and pick up where I left off. In this case, I will just go with this other tab that I have open to prevent my demo from failing on me in the event of technical difficulties. So, what are we actually going to be demoing? Who here is a baseball fan? 3 people, that's tough. Who here knows what baseball is? There we go. So we're gonna be looking at MLB's StatCast data. Who knows what StatCast is? Probably, 2 people. So small sample size there. That's all right. So StatCast is this system that's in these MLB ballparks, and it's collecting data of games that are ongoing. And so it's not just collecting batting average and strikes and balls. It's getting very, very sophisticated data using very high-speed cameras. So we're talking about things like the position of a pitcher's arm in certain millisecond intervals. So we can see the X, Y, and Z coordinates of where the players are, where an arm is moving, how a bat's moving. There are some interesting stories of teams using this data with their hitters to get them out of a slump, where they can tell that someone's trying to swing the bat. They're swinging it at an angle that's too low or a couple degrees off from where they normally would. And they can make tiny adjustments and have large impacts. So that's the kind of data that we're dealing with here. It's very large data that's often collected in real time by the teams during the games. But this is also made available online, so we can just access this on the web. So we're gonna read in this data. We'll take a look at what that raw StatCast data looks like. We'll transform this into something that's a little bit more workable. I'll talk about some of the things I discovered that in the data that weren't quite right. And then we will create our table, query it, get some interesting insights out of it, and then create a dashboard. So what we're looking at here is one of our notebooks. And the way that these notebooks work, if I want to run a command, it has to be attached to some cluster. And so we can see on the top right here, this is where I go to attach it to a cluster. Right now we have some shared clusters running that this is on. But if I wanted to create my own, I'll go down into this Compute tab on the left. So there are a couple of pieces of code in here that I won't talk too much about the specifics itself, but I'll just kind of describe what's happening. The way that this data is made available to us is through a Python package called PyBaseball, so you can see there. So we install this package, and then we can very easily access this data. For the sake of this demo, I'm just accessing data over the web using this package, but there are many other ways that we could do this. So primarily, if I actually go into the Data tab and click on Add Data, I can see a lot of the native integrations that we have, so I can pull directly from these sources. And I can see as well some of the sources I can pull from with help from some partners. As well, I could upload data directly in here. Let's say I'm interested in a partner. I can come down to Partner Connect. I can take a look at all the partners that Databricks has native integrations with and start to pull in data using these partners. As well, this is where you might go to configure BI integrations with Power BI, Tableau, wherever it might be. Finally, a relatively new feature for us is Marketplace. So we have a lot of organizations that are putting data on the Marketplace that you can go ahead and access. And so this is now generally available. All right, I'll go back to my notebook. So I install PyBaseball. I create a date variable. I'm going to tell PyBaseball that I want all the data for this year. It has data going back to 2016. All I want is from March 30th to yesterday. And I'm creating this date variable yesterday so I can always be getting the data up till yesterday. A few lines of code, I pull in that data. Here's what this looks like. I get a little brief preview of this in the notebook. Just going through it, a lot of this looks relatively familiar. I can understand some of what's going on here. We have player names. We have descriptions of what happened. That's easy enough. Game date and time, that's not really ideal. I might not like that. Pitch type, we'll see below. I tried to figure out what all these pitch types are. There were 21 different pitch types that have been thrown so far this year, and I could not identify the vast majority of them, so I left that alone. But the problem is, I have data in this table that I don't know what it means, and so I have to do some transformations. I have to fix this up. And we'll see below as well, we can actually visualize data directly in the notebooks. And so I created my table, I tried to visualize something. I tried to take some average and get some nice chart to appear, and nothing worked. And figured out that actually, all the data is made available to us as strings. So I can't manipulate this in any way other than strings. So I do some more transformations so that we can get this into something that's a little bit more workable, something that we can properly do analysis on. So I can hand that off to my baseball analyst, my data scientist. So again, I'll gloss over some of the code here. We have a UDF just to fix some of the data types when we're converting to start using Spark. I do some transformations to get the desired look of the data. You can see a couple at the top here where the game type typically is represented just with a letter. And what I needed was the actual words. I don't know if somebody said game type F, I wouldn't know that's a wildcard playoff game. And there seems to be no relationship. So we make some transformations. You can see here as well, I am casting some of these columns to different data types before we end up with a data frame that's a bit more workable. And then we go ahead and we create a table off of that. So it's at this time, I actually switched to using SQL. And so in the notebook, you can see at the top, I have this option that's a dropdown that says Python. If I want, I can flip this to any language that's available in this dropdown, so SQL, Scala, and R. And that'll make the default language for the entire notebook, whatever language you select. However, if you want to start using other languages, as you can see in that one SQL cell, I use what's called a magic command. I say % followed by SQL. Change the language in that cell so I can start coding in SQL. And I create a table, I select some columns. My table is called baseball data, and I want to see what this looks like. So basic SQL again, I have a table that looks a little more reasonable. I know the data types are as desired, and now I might start trying to manipulate this. So just to confirm, I created a little visualization here. This just shows pitch speed over innings. So for those of you that are not familiar with baseball, there is a lot of throwing of the ball on the pitcher's mound. I wish I had the time to explain baseball for those who do not know, but thankfully we do have a good chunk of people who do know what it is. And so we can see it starts out at the beginning of the game, around about just under 90 miles an hour on average, which does actually seem a little bit low. So 90 miles an hour, and I can see it steadily drop off over the first 5 innings, and that kind of makes sense. You might have the same guy out there for a while, he gets tired, and over the first 5 innings, you can start to see the pitch speed go down. Then it goes up in the 6th inning, which says to me that that's on average when relief pitchers are coming in. So we bring in somebody else who's got a fresh arm. And then usually it's at the ninth inning, or usually in the ninth, and as we get later in the game, we see closers come in, closing pitchers, who usually are throwing much, much faster. And so that all makes sense. But then we have some interesting data from extra innings. For some reason in the 13th inning, it just drops off a cliff, which I cannot explain. Maybe at that point, teams are giving up and they're just trying to get the game over with. Who knows? So anyway, the data looks about right. I'm seeing something interesting. Maybe I dive deeper into that. I can continue to do some analysis in the notebook. But otherwise, I have a table that I'm happy with. And now I'll go over to the SQL editor, and we'll actually start to just code in straight SQL, write some basic queries, visualize, put in a dashboard. Before I do that, however, I did want to stop and take a look again at some of this Python that's up here. If you're not familiar with Python, this is not very attractive. Like it's fine, but it's complicated, and it makes Databricks look complicated. But actually, a lot of the code that I got to make this, I took from what we call solution accelerators. And so Databricks has a lot of solution accelerators for different industries. Maybe if you're in financial services, then we have fraud detection solution accelerators. If you're in retail CPG, then there's churn prediction solution accelerators. And effectively what these are is it's pre-built code that's going to take you 90% of the way to accomplishing some use case. So in this case, I had a lot of code that one of the other solution architects at Databricks, Max Wittenberg, previously had put together. And so I took a lot of his code, and really the only things, I had to make a couple adjustments in the code there, and then after that all I had to do was write a couple SQL statements and create my tables, and I was off to the races. So this was super easy for me to do because a lot of it was done for me. If that's interesting, there are a lot of solution accelerators for all industries online. I'd encourage you to go to the website and check them all out. It's all free to download. All the notebooks are there. You can take the notebook and upload it right into Databricks and get going. Okay, so now let's do it. I move over to my SQL editor. I have my table. I want to start writing some queries. So I've got 4 here that I've done, just something rather basic. This first one is showing me fastest pitches so far this year, so top 10 fastest pitches. And it's absolutely dominated by somebody on the Twins, whose first name I dare not pronounce, but Duran we'll go with, throwing 105 miles an hour, which is ridiculous. And he's got, what is that, 7 of the top 10, all of the top 7. Jesus. Okay, so I have my results there. That's great. Let's ask a different question. What about average pitch speed? And I want to see the volume of that as well. So I can see who's the fastest pitcher on average. What's interesting is the individual that we saw before, Duran, his average goes down to 96, which means he's throwing something off speed that's way slower. Interesting. Next, we've got home runs per inning. So over the 9 innings, where are we hitting the most home runs? Right in the SQL editor here as well, I can just immediately switch to a visualization. And so I created a little bar chart just to help kind of inform what this data looks like a little bit more. Interesting. 9th inning, it goes way down. It kind of makes sense. Sometimes if the home team is winning in the bottom of the 9th inning, there's no need for them to come to bat. So sometimes you don't play the bottom of the 9th inning, and it lends itself to then not having as many home runs. But why there's a dip in the 2nd inning is strange to me. Maybe in the back half, 6, 7, and 8, they're getting tired, and so there's fewer home runs, or maybe at that point the score is 14-0, as I'm sure my Phillies are gonna do once again very soon. And maybe they just give up, who knows? But the 2nd inning is odd. But that's all right. That's good information for me to know. These are the kind of visualizations I'll put in a dashboard, and I want to track this every day. And so once I have my queries complete, we'll put this in the dashboard, and we'll schedule all of this. Finally, my personal favorite, just hit distance. So for all of the hits that have occurred this year in Major League Baseball, in aggregate, how far have they traveled? 771 miles for baseball traveled this year. If I'm a baseball analyst, Probably not that helpful, but for people who aren't necessarily baseball fans, interesting. So I have my queries. I've done some basic visualizations. If I want to add a visualization right here in the editor, I'll click this plus button, click visualization, and I'm off. I can see I've got different visualization types I can select from, and then a whole host of different ways to continue to edit this with colors, with labels, whatever it might be. Very kind of standard tools for editing dashboards. So I'm good. I don't want to create anything now. I have a few that I like. So I'll check out my dashboard. Here's what my dashboard looks like using those queries, using some of those visualizations. If I wanted to add a visualization, I'll come over to my 3 dots, click Edit. I can click Add, and once again, we're doing the same thing. In this case, I just select the query I want to use, so maybe I'm going to visualize that hit distance in some other way. I can select the existing visualization, which is what I have here now, or I can use this counter, or we can create a new one. If we create a new one, it'll take you to the same screen we saw before, and we create the visualization from there. So, a couple other things to call out. We'll go into the queries section itself and take a look. I can see all queries across my organization. I can see just my queries, queries that I favorited. I can create from over here. Down in the Alerts tab, I can set up alerts so that if I run something and the query then meets some threshold, something gets presented to me, then I can have that notify me immediately. Okay. I'll go back to my dashboard. My dashboards. So this is great. I have what I need. I now want to have this refresh automatically every day. And you can see at the top, there's the manual button to refresh. There's also the button to schedule. So I can define a schedule here, and I can just have the dashboard itself refresh. As well, I can go back into my notebook. So let's go then back into my notebook. And I can schedule this as well. And I can define a schedule in the top right. In this case, I already have a schedule defined, so we'll take a look at this job that I've already created. Or we can also add a schedule down here. If I add a schedule, it asks me a lot of similar questions. What compute resource do I want to use? What is the time over which, or with which we want this to refresh? So again, in this case, I already have a schedule. So I'll just go into the workflow itself. So on the left side here, we can see the workflows tab. I will select the job that I've made. We can see some information about the past runs here. So I ran this a couple times, it failed a couple times in my testing. And then we can actually see what does this job consist of. So on the left, I've got my notebook. I have this scheduled to run first. Once this completes, using this UI, I then have my dashboard scheduled to refresh immediately after that. A couple things to call out. On my first task, on my notebook, I've set a notification on the right so that it will notify me if this fails. I'll get an email that says this job failed, and it'll give me the link to go and check it out. As well, you can set that for if it succeeds. You can set that for once the job starts, you can be notified. Now looking at the dashboard, again, we select the compute resource that we want to use when that dashboard refresh triggers. But then as well, I have this subscribers section filled out. And so what this is saying that every time this completes, send a snapshot of what that dashboard looks like to these individuals. And we put our email title in there. And then once a day, at the right time, I get an email from Databricks with my snapshot of what this looks like. And so we've gone from ingesting data, using the StatCast data, we've pulled that in, many other ways to do that. We just did that programmatically. I then transformed this data, just needed to fix some data types, needed to clean up some of the data. I create my table very simply. I'm able to access that in Databricks SQL. I query, I build some visualizations right in the query editor. Easy for me to add those to a dashboard. And then I can take both the pipeline that I built that's pulling in that data. I can take the dashboard that I created, schedule those to run together. And so then I end up with my end result, which gets emailed to me once a day. So, with that said, we've gone very simply from start to finish, ingest data, get our insights out of this. If I'm a baseball team, I'm now able to get these insights on a daily basis. I've asked questions of data very quickly. I've been able to get access to this data source that's kind of difficult to wrangle otherwise very quickly. And they can continue to manipulate this. They can continue to do more sophisticated analytics. I know the Texas Rangers are presenting at Data and AI Summit. If you're interested in baseball now, because this was incredibly thrilling, you can go and see what the Texas Rangers have to say. But otherwise, I will be around for any questions. And I think we actually have some time for some questions. But otherwise, thanks very much. And I'm looking forward. I enjoy the rest of the summit. And if there's other parts of the platform that are interesting, you'd like to see more, then you can scan the QR code and it'll take you in the direction of some other sessions. Thank you very much.